What comes to your mind when you think about encryption? Encryption is not a recent idea to humans due to our inner desire to conceal things from unwanted parties. We had code names we used to call our parents when we was kids. The Egyptians started using non-standard hieroglyphs around 1900 BC, while the Spartans used the Skythe cipher. Encryption is the process of converting plain readable text, which is often called the plain text, into an unreadable format, which is called the ciphertext, using mathematical algorithms and keys. This ensures that only authorized parties with the correct decryption key can access the original information. Encryption can be broadly classified into two main types: symmetric encryption and asymmetric encryption. In today's video, we will learn how to encrypt data symmetrically and asymmetrically using Node.js. We will not stop there because I will show you how to apply what we will learn today inside a real-world application. I will show you how to securely encrypt sensitive user data and also how to encrypt and store a file. So if that makes sense to you, then absolutely smash the like button and ensure you subscribe to the channel and turn on the bell notification to get access to all of our videos as they drop. Make sure to leave your thoughts on the video via the comment section. I would love to read that. So let's dive into the code for today. I will import create cipher IV from the crypto library. I will create a function encrypt symmetric, which will handle symmetric encryption of data. This function accepts two arguments: a key, which is a string representing the encryption key, and a plain text, which is the text to be encrypted. Inside the function, I will create an initialization vector using the random bytes function, which can be imported from the crypto library. Next, I will create a cipher which is equal to the result of calling the create cipher IV function we imported. We need to pass an encryption algorithm to this function as its first argument, and that will be AES256 GCM. We'll pass the encryption key as the second argument to the create cipher IV function, and finally the initialization vector becomes the last argument. I will create a ciphertext which is the result of calling the update method on the cipher. The first argument we pass to this method is the plain text we want to encrypt. The next is the encoding for the data we are encrypting, while the last argument is the encoding of the encrypted output. Then I will call cipher.final with hex again and append it to the ciphertext. We will create an auth tag by calling the getAuth method on the cipher and storing the result in a variable tag. Then I will return an object from this function. This object will have an IV property which is equal to the result of calling the toString method with hex on the initialization vector. It will also have a tag property. It will have a ciphertext property. Let's go ahead and test this out by creating a key using the random bytes function. Then I will create a message with sensitive data. I will call the encrypt symmetric function with the key and the message. Then I will console log the encrypted data, and you can see that it has an IV property, an auth property, and a ciphertext property. Next, let's see how we can decipher this back into its original form. Next, I will create a function, decrypt symmetric, which accepts four arguments. The encryption key is the first one. The initialization vector will become the second argument, the ciphertext will become the third argument, and the auth tag will become the last argument. Inside this function, I will import and call the create decipher IV function from the crypto library. I will call the function with AES256 GCM as the decryption algorithm. I use 128 here, but this is a bug that I will have to fix later. This must be the same as what we used when encrypting the data. I will pass the key as the second argument to the create decipher IV function, and the last argument will be a buffer created from the initialization vector. Next, I will call decipher.setAuth tag with a buffer created from the auth tag. I will create a variable decrypted, which is equal to the result of calling the update method with the ciphertext on the decipher object. Then I will call decipher.final and append the value returned to the decrypted string. I will return the decrypted string from the function. I'm going to go ahead and call the decrypt symmetric function with the key, the encrypted.iv, the encrypted.ciphertext, and finally the encrypted.tag. Then I'm going to console log the data just to be sure it is the same as what we encrypted. We get an error, invalid key length, and this is because we used the wrong decryption key. We have to fix that and run the app from the terminal again, and you can see that it is being encrypted and decrypted successfully. Now let's go ahead and look at asymmetric encryption. I will import and call the generate key pair sync function from the crypto module. The first argument is the encryption algorithm and it's going to be RSA. The modulus length will be 4096. The public key encoding will be of type SPKI and the format will be PEM. While for the private key encoding, the type will be PKCS8 and the format will also be PEM. I will destructure out the private key and the public key, and then I will console log RSA keys generated successfully and run the app from the terminal. You will observe that we get a message in the console: RSA keys generated successfully. The public key can be used to encrypt data, while only the private key can be used to decrypt data. First, let's see how we can encrypt data with the public key. Next, I will create a message which is equal to the result of importing and calling the read file sync function from the FS module, and then I will pass in a path that matches index.txt while the encoding will be UTF-8. I will import and call the public encrypt function from the crypto library, passing in the public key as an argument to it, while the second argument will be a buffer created from the message. After that, I will call the write file sync method to write the encrypted data to a file named message.txt. Then I will create the index.txt file and add a text secret to it. All of this is done from the terminal using echo. If I run this app from the terminal, you can observe that we now get a new file in the directory message.txt with the encrypted data. Let's see how we can decrypt this data using the private decrypt function. First, I will call the read file sync method with the message.txt file and store the result in a variable secret, after which I will import and call private decrypt from the Node standard library. I'm going to call this function with the private key and a buffer created from the secret, and I will console log the decrypted string. If I run this app from the terminal, you will see the decrypted secret. We need to see how to verify that data came from a trusted party using data signatures. Okay, I will create a function create signature which accepts two arguments: private key, which is a string, and data, which is a string or buffer. And inside this function, I will import and call the create sign function from the crypto library. The encryption algorithm will be RSA SHA-256. I will chain a call to the update method with the data and store the result in a variable sign. Then I'm going to return a call to sign.sign with the private key and hex as the encoding format. Next, I will create another function, verify signature, which accepts three arguments: the public key, which is a string, the data that was signed, and the signature of the data. Inside the function, I will import and call the create verify function with RSA SHA-256 as the encryption algorithm. Then I will chain a call to the update method with the data. I will chain another call to the end method, and finally I will store the results returned in the variable verify. I will return a call to verify.verify from this function with the public key, the signature, and hex from the verify signature function. I'm going to go ahead and test this out by first creating a signature which I will console log, and then I'm going to attempt to verify that signature, and I will also console log the verification. And you can see that we get the encoded signature and a boolean which is actually true. Normally I would stop here, but because I told you that I'm going to show you how to encrypt sensitive data and how to securely encrypt and store a file, we still have to go ahead. So let's see how we can encrypt and store sensitive user data. I'm going to show you one example of how to use symmetric encryption in your code. This is applicable in a real world app. Okay, I will ensure I export all the functions we have defined in the index.ts file, and I will also export the private and public keys. Then I will create a new file, user.ts, and inside this file I will import random bytes from the crypto library and use that to create a 32-bit encryption key which is in base 64 format. I will also create a buffer from that key. Then I will create a new class, user encryptor. Inside this class I will add a constructor function, and inside this function I will set the algorithm to be equal to AES256 GCM. Not that we will actually even use it. Then I will ensure I define the algorithm property on the class, and I will add a new method, encrypt sensitive data, which accepts a data argument, and inside the function I will import and call the encrypt symmetric function. I will pass the encryption key and a JSON from the data passed into the encrypt sensitive data function as the second argument to it. I will return the result from the function, and then I will add a second method to the user encryptor class. This method will be named decrypt sensitive data, and it's going to accept a single argument, which is the encrypted data. This encrypted data, we have an ivory property, an auth tag, and a ciphertext. And inside the function, I will structure add the IV, the tag, and the ciphertext. Then I will import and use the decrypt symmetric function, passing in the encryption key, the IV, the ciphertext, and the tag. Then I will store the results returned in a variable, the cipher, which I will return from the function. I will add a new function, create user, which accepts a single argument, user data. And inside this function, we need to instantiate the user encryptor class. We are now trying to simulate the process of creating a user and storing their sensitive data. Okay, that is, we have to encrypt it first and store it. Then I'm going to use the encrypt sensitive data method to encrypt some sensitive user data like their social security number, their credit card details, and their medical records. Okay, since these are all personal data we can now simulate the process of creating the user and saving it to the database. If we want to retrieve the user, we define a new function, getUser, which accepts a user ID argument, which is the ID of the user, and inside the function we will instantiate the user encryptor class. Then we will simulate the process of fetching the user from the database. So once we have that user, we can now use the encryptor to decrypt their sensitive data and return it from the function. Okay, remember that I said that we can also use symmetric encryption for secure file storage by encrypting the contents of the file before storing it. First, we need to delete all of the existing code we have written except for the import statements. Then I will import pipeline from the stream module. Then I will declare a class secure file storage, and inside it I will add a constructor function where I will declare a private key property, which is a string or buffer, and then I will define an encryption function which accepts two arguments, an input part for the file we are trying to encrypt and the output part for the file after we finish encrypting it. Inside the function, I will create a read stream from the input part, and I will also create a write stream from the output part. Then I will head back to the indexed file where I will define a new function, encrypt file. I will export this function from this file, and this function will accept three arguments: the encryption key, the input, and the output. Inside the function, I will create an initialization vector. Then I will create a cipher using the AES256 GCM algorithm with the key and the initialization vector. Then I will change the types for the output and input argument to be write stream and read stream respectively. Then I will use the pipeline to funnel the data from the input, transforming it with the cipher since ciphers are transform streams. And finally, I'm going to write the encrypted data to the output. I will create an auth tag from the cipher and return an object with a tag property, an IV property, and a cipher property. I will then import and use this function inside the encrypt method on the secure file storage object. I will call await encrypt file with the key, the input, and the output, and then I will use the append file synchronous method to append the tag to the beginning of the file and return the output from this function. I will define another method on the secure file storage class. This method will accept two arguments, an input part which is a string and an output part which is also a string. Inside the method, I will use the start sync function to fetch the file stats. Then I will retrieve the file size from the file stats. I will create an initialization vector which will be an empty buffer for now. I will also create a tag which will be an empty buffer. Next, I will create a file descriptor using the OpenSync method, which can be imported from the FS module. I will use the input part to find the file, and I will pass in the R flag, which indicates that we want to read the file. I will head back to the index.ts file where I will define and export a new function, decrypt file. Inside this function, I will copy and paste some code that we already know. I am now reading the tag and the IV from the file and closing it. After that, we need to accept some arguments into this function, which are the file descriptor and the file size. Obviously, we also need to accept the key as a string or buffer into this function. Next, I will create a decipher IV with the key and the initialization vector, and then I will set the tag on the decipher object. I will in fact change the type of the argument to be an object because we need to accept an input and an output into this function, and after that I will await a call to the pipeline to pipe the data from the input to the decipher to decrypt it before writing it to the output. I will head back to the user.cs file where I will import and call the decrypt file function, passing in the key, the file descriptor, the size, the input and the output arguments. And I will instantiate the secure file storage. After that, I will define an async function handle storage, and inside it I will encrypt a file index.txt into a message.txt. I have to move the input and output initialization out of the function call to outside it, and then I will console log encrypted. I will in turn decrypt the file message.txt into an output file decrypted.txt, and then I will console log decrypted and call the handle storage function, and then I will run the app from the terminal, and you can observe that if I open up the message file, you can see the encrypted contents which you cannot do anything with. However, if I go ahead and open up the decrypted.txt file, you will see the decrypted file with its original contents. We can use asymmetric encryption for securely encrypting and storing messages exchanged between two users, or we can also use it for secure data exchange between two applications. So definitely leave your comments in the comment section about this video. Leave this video a like if you enjoyed it, and if you want to see more examples of how to use encryption in your live application to secure your users' data, ensure you subscribe to the channel and turn on the bell notification so you don't miss any of our videos as they drop, and I'm going to see you in the next one.